Hello, and welcome to the Building Secure IoT Solutions with Azure Sphere and IoT Central. My name is Dave Glover. I'm a cloud developer advocate based in Sydney, Australia, and have a focus on the Internet of Things. Now, do feel free to follow me on Twitter and also on LinkedIn. Now, it's also my great pleasure to introduce Mustafa, who's one of our student ambassadors based in India. Mustafa, would you like to introduce yourself and tell us a bit about yourself?
Yes, thank you, Dave. So, hello everyone. I am Mustafa Saifee from Maharashtra, India, and I have been a Microsoft Student Ambassador for the past 5 years. And this is my final year in my engineering. And you can follow me at I am Mustu, and on LinkedIn you can find me as Saifee Mustafa Q. Thank you, Dave.
That's great. Thanks, Mustafa. And thanks for taking the time out. I know it's pretty late there in India as well. Now, security is without a doubt one of the biggest challenges facing the IoT industry, and it is often overlooked and really a rush to get products out to market. Now, IoT and security should really be it really should be the heart of every IoT discussion. Now, this session actually builds on a session that we did last week. In fact, you'll find the link down there at the bottom of this page, aka.ms/IoT Oxford. Now, there are some parts of this presentation that repeat, particularly at the beginning, or that the same as last week. Do hang in there because I can promise you that it will get different very quickly. Now, Azure Sphere is our platform for building highly secure devices that are secure by default. Now, in partnership with Oxford University, we have actually developed these Microsoft Learning modules, which focus on the Azure Sphere. And this presentation is really in support of these modules. So you can find a lot more detail there at aka.ms/learn-IoT-central. Now, at that module, you'll find all the description and all the source code. So keep in mind that as we go through the demos, in some places we'll be going too fast for it to be able to take on all that's happening, but all the documentation and all the source code for this talk, you'll find that link. Now, there will also be some moderators standing by to answer any questions. So please feel free to ask any questions on Twitter and use the hashtag LearnTV. I'll also do my best to keep an eye on the questions as they come through as well, and we'll try and answer those during the talk. So the talk is most definitely live. Now, the agenda for this session here, we're going to look at just kind of IoT security risks in general. We're going to look at Azure Sphere security, creating Azure IoT Central applications. We're going to create an Azure Sphere application, and then we're going to be able to remotely control the IoT, so the Azure Sphere from IoT Central. Now, Mustafa, would you like to talk to us a bit about the scenario for the lab scenario?
Yes, so let's assume that you are a scientist in a microbiology laboratory and you're responsible for storing samples from a test. Now, as you're working in a lab, you want to build a system that monitors a few environmental conditions for the lab equipments in real time. Now, these conditions are pressure, light, humidity, and temperature. Now, previously, these were recorded manually by the lab assistants using sensors at regular intervals. Now, manual recording can be tedious and as well as prone to human error. Now, having any issues with these sensors could invalidate the test results that you worked so hard on. Now, maintaining the room conditions accurately is critical for managing the laboratory, and the lab needs to maintain the right conditions to help you get more accurate results. Any variation in the equipment can spoil your results, specimens, and lab equipments. This could impact the ability to produce the correct and stable results and have economic impact on the organization. So these kind of scenarios with an error happen every day. And maybe Dave, can you show us some headlines that show how IoT was used? It was not intended to use.
Yeah, hey, thanks, Mustafa. Hey, look, it's pretty rare for a day to go past where there isn't some headline story about IoT security. Now, this could be gadgets, it could be children's toys, it could be vacuum cleaners that have been used to spy on families. There's even been situations where we've had things like heart pacemakers that have been hijacked, or car security systems that have also been hijacked. And there's been plenty of attacks, or well-known attacks on cyber attacks on cities, and also the well-known Myra botnet attack, which took over a huge number of security cameras because they were using weak passwords. And then they used those cameras to actually go and do a denial of service attack on DNS servers supporting the infrastructure in the US. and actually brought down the East Coast internet for a day. So these attacks are absolutely real, and it's something that we need to be constantly thinking about and mitigating against. So, Mustafa, would you like to talk a bit about the casino fish tank attack?
Yes, so this was a very small incident, but it was a very huge impact on the casino. So this casino had a very nice fancy fish tank. It had all the automation units, sensors, cameras, everything installed in a small fish tank. What these hackers did was they got into the secure system of this casino via this IoT system, via the sensors in the fish tank. Now, by the time the authorities realized that someone is in, these notorious hackers, they had already downloaded a lot of data and the damage was already done. Now, although they recovered from it, but still we can see that how IoT is not secure nowadays. Maybe now, Dave, can you tell us how Azure Sphere can address this security issue?
Yeah, hey, thanks. Yeah, it's pretty crazy kind of attack. You would think putting a sensor in a fish tank would be a safe enough thing to do, and I guess it did a lot of things a lot of things wrong. I think for one thing, they had the IoT devices also connected up to their corporate network, which probably wasn't necessarily the smartest move. Next thing I want to talk about is approaches to mitigating security risks. Now, I'm sure you appreciate that security is very much a journey. It's complex, expensive, and it's ongoing. And the security of attack vectors are constantly changing and getting much more cunning. Now, Microsoft has a long history in building secure internet connected systems, and we're taking those lessons and applying those to Azure Sphere. Now, Microsoft and the industry have come up with 7 properties that are required for building highly secured devices. Now, I'm not going to go through these blow by blow, but you'll see down the bottom of this page, the aks.ms/7 properties, and you'll find a whole lot more information about these 7 properties and a lot more detail. But kind of touching on a couple of these things, so we've got things like a hardware root of trust, which is a set of unforgeable cryptographic keys that are protected by hardware that identify the device. We've got certificate-based authentication, because we know that a lot of devices out there will typically use weak passwords that can be easily cracked. So if you're using certificate-based authentication, it makes the security much tighter for authenticating those devices. And of course, things like error reporting are super critical. If you don't know a device is being attacked and you can't report on it, then you don't know what's happening, and then of course you can't mitigate against it. So error reporting is super important. Now, Azure Sphere is made up of 3 components that together implement these 7 properties. So the first component is the Azure Sphere microcontroller itself. Now, this is a multi-core microcontroller, which ships with a hardware root of trust. Now, there's the Azure Sphere operating system, which is ongoing updates. Now, interesting enough, it's actually a hardened version of embedded Linux, which is actually supporting underpinning the Azure Sphere operating system. And then there's a cloud service called the Azure Sphere Security Service, and its role really is to kind of protect and broker trust between the devices and the cloud, making sure that security certificates and all those types of things are up to date, detecting emerging threats, renewing device security, and app reporting. Now, as I just mentioned, the Azure Sphere microcontroller is what's called a multi-core microcontroller, and it's made up of a number of components. So you'll see that the 2 boxes that are outlined in red are the cores that you can go and deliver your applications onto. So there are 2 Cortex M4 microcontroller cores that you can go and deploy bare metal applications, tiny machine learning models, FreeRTOS, and Azure RTOS. Those are style of applications you're going to deploy onto those cores. And we also have a Cortex A7. And this Cortex, this core is responsible for running the operating system, but plus you can deploy your own what we call high-level application to that core as well. And you'll notice up on the top left-hand corner is something called the Microsoft Pluton security subsystem. And it is running on another core, another protected core, and its role is really to implement security policy. Plus, as you'd expect, there's network connectivity cores, and there's memory, and there's storage, and things like that. But the other thing I should like to point out is the firewall. Now, the firewall is a bit broader than what most of us would think about firewalls. So the firewall, not only does it protect network endpoints, but it also protects hardware. So as I mentioned before, these devices are secured by default and everything is locked down unless you explicitly enable a peripheral, for example, GPIO, or explicitly enable a network endpoint. So everything is locked down by default. Now, Mustafa, can you talk to us about the developer boards that are available for building on Azure Sphere?
Sure, Dave. Thank you. So there are multiple developer boards you need to connect your IoT system to Azure. So one of the most popular board developed by Avnet is the Avnet board. Now this board has a lot of modules, a lot of options that you can attach to it. There are click slots, there are groove slots. So what are click slots are? There are small modules of click that are already available off the shelf. You can just grab a click slot and put it in the slot and your sensor is up and running. The same with groove connections. You can just attach it. Now there is another board by Seed, that is MT3620 development board. It has a lot of GPIO pins and you can attach a lot of sensors to it. There is another board that is a mini version of this previous Seed board. It is MT3620 mini board. It has a little less GPIO pins but very useful, and you can use any one of them to get your application running. Yes.
That's great. Thank you very much. And of course, as Mustafa mentioned, there are lots of extension boards out there, and also you'll find lots of device drivers for these boards, typically from the manufacturers' websites, to go and extend your solutions with those prototyping boards. Now, as I mentioned at the beginning of the session, I'm going to be talking about Azure Sphere, but I also mentioned that the Cortex M4 cores, you can run a real-time operating system. Now, the real-time operating system that we're going to run on one of the Cortex M4s is called Azure RTOS. Now, if you've been around in the industry for a while, you might also know it as Express Logic. So it was an acquisition about a year ago, and it's been rebranded as Azure RTOS. And it consists of a number of components. Now, the component that we're going to be using in conjunction or running this on the Azure Sphere, we're going to be using something called ThreadX, which is the real-time operating system. Now, there are a number of other components which are really much more applicable if you're deploying a device kind of outside of the world of Azure Sphere. So you'll tend to see Azure RTOS in a lot of embedded devices, particularly very resource-constrained devices. Now, you'll find information about Azure RTOS at the link below, so azure.microsoft.com/RTOS, or just go and search for Azure RTOS to find more about it. Now, the bit that I mentioned that we're going to be using in a bit more detail is this thing called ThreadX. So as I said before, ThreadX is a real-time operating system. So you often see that referred to as an RTOS. And it basically delivers a threading environment. So you have preemptive threads, and so threading services. You also have services like message queues. You have mutexes and semaphores. So things, for example, of coordinating activities between multiple threads that are running on this core. You've got services there for allocating memory, and of course you've got the ThreadX core scheduler. So you'll see that a bit in action. Now, we're not going to delve into that in the code a lot of detail. Just keep in mind that it is in the repo that you will be cloning down when you start off the learning module. Now, the components that you need for this learning module, you'll need to sign up to Azure IOT Central. Now, there is a free trial, and we're going to show you how to create a new application or new template in that. You'll obviously need an Azure Sphere. If you don't have an Azure Sphere, of course, there's nothing to stop you going looking the learning module and just kind of reading through it and just working through it to get an idea how it works. So we mentioned the Azure Sphere modules. There are 3 on market at the moment. So the 1 from Avnet and 2 from Seed Studio. You need to install the Azure Sphere SDK, the Software Developers Kit, and you can go and build applications on Windows and on Linux. Keep in mind, it is a C development environment. So we are talking about microcontrollers, highly constrained environments, and the development environment is C. You'll also need to set up an Azure Sphere tenant and authenticate against that, and you need to claim your device into that. And that's a one-off operation and enables you to remotely control and manage these Azure Spheres. Keep in mind that there are also what we call roles. So you can have multiple people who can authenticate into your tenant, and you can define different levels of roles. So for example, you can have an administrator and a content developer inside those roles. The first thing you normally want to go and do is update the Azure Sphere OS operating system And you'll find details on how to do that in the learning module. And of course, there's the Azure Sphere Security Service, which I mentioned before, is a thing that's kind of sitting there providing all the ongoing updates, error reporting, certificate renewal, and stuff like that. Okay, so what we're going to be doing, and this is a part where the talk gets very much different from the talk we did last week. So what we're going to be doing is we're going to be using IOT Central. Now, if you're not familiar with IOT Central, it's a managed service. So you can go and build backend or kind of a web portal for an IoT solution. And it's the beauty of it is it enables you to bring and demonstrate the value of an IoT solution super quickly without requiring a lot of developer skills in the cloud. So very much drag and drop, go and define the objects, and then map those into some sort of charts and graphs and reports. And you can go and define rules and triggers. And it's also extensible. You can go and extend it into flow dynamics, various things like webhooks. So super easy way to go and really demonstrate the value that IoT can bring. Again, if you're working on a project, it's a great place to start to really simplify your development. Now, IOT Central itself is an application that is built on Azure IoT Hub. So we talked about IoT Hub in last week's talk in much more detail, but it's as a service, kind of internet scale service that is responsible for bidirectional communication and messaging between a device and the cloud. So internet scale communications and messaging. It's also built on something called Azure Sphere Device Provisioning Service. And it is there for what we call zero touch deployment or provisioning. Again, for provisioning hundreds of thousands of devices, makes it much simpler to go and provision those devices without having to do things like hard code and connection strings into the device, which becomes very unmanageable very quickly. We've got something called Azure IoT Plug and Play, and it's a way in which you can define as a specification for it. And it's a way in which, if you're creating these devices, you can define basically a JSON document which describes these devices. And IoT Central is a plug and play compliant application, so you can import those templates, and then you're pretty much most of the way to creating your application. And Azure IoT Time Series Insights is there for providing in-depth reporting, so you can delve into the data and look at the history of what's been going on with your IoT devices in a lot of detail. And as I mentioned before, those core services are being used by IoT Central, kind of underpinning IoT Central as an application. So the first thing we're going to do is that Mustafa is actually going to create an IoT Central template and just kind of go through the process. Now, I've already created the template, and Mustafa is going to show you how you can import that and go and define the application. So Mustafa, I'd like to share your screen and just take us a quick demo.
Yes, so first of all, we'll head over to the dashboard and we'll go to device templates. Now we have to create a new template for that. And then we have to go to IoT device, next customize, and let's give the template a name as learn TV monitor. And then we'll review it and create. It will take a few seconds, and that's it. And now we want to import the capability model, which will be a JSON file. And Dave has already prepared this JSON file. I'll just import it. So this JSON file has properties such as temperature, pressure, and all of that. We'll go into views. Name this as properties. And then we'll add the sample rate seconds, add section, and then we'll save it. Then we have to head over to the views. And we have to visualize the device, all the data that we are talking about, the telemetry, right? So we have to view the telemetry as well. Telemetry. And then what we want is temperature and pressure. And I'll add the tile, I'll save it. And that's it, and I'll publish it.
That's perfect.
Yes.
Okay, great. If you're going to look on the devices tab.
So when you go to the devices tab, you can go into lab monitor and click on Azure template you created.
Okay, because I stopped the device, so the data is not going up there at the moment. Okay, we'll see that in action shortly. Hey, thank you much for that, Mustafa. So that was awesome. Okay, so we'll just jump back to my screen. Okay, so thank you for that. So as you can see, it's a pretty straightforward process to go and create an IoT Central application. Now, that template that Mustafa used, you'll find as part of the learning module. And effectively, the way I created that template, just so you know, is I went and created the template by hand and then I exported it. Somebody asked me recently, how did I actually go and do that? So that was the process by which I created that. Okay, so now, as I mentioned before, we're gonna build an application which is going to run across two cores. So we're going to put an application on the Cortex A7, which is what we know, which you will see in the documentation was referred to as a high-level application. Now, remember, the applications running on the Cortex A7 include the operating system, update services, and things like that, plus your application. So your application on this is not real-time capable. So just keep that in mind. And that's typically why we'd go and use and run an application on a real-time core, is where you've got an application which requires real-time capabilities. And what do I mean by that? It's, for example, you might have a sensor which wants highly deterministic timing, highly precise timing for it to operate correctly. So you might run the applications like that on the real-time core. As I mentioned before, you could also go and run, for example, a tiny machine learning model. Perhaps you want to go and build a voice-activated solution, and you want to go and run that tiny machine learning model on a Cortex M4 and offload that processing onto a separate core and keep your main application running on the Cortex A7 core. So now the way that these applications communicate, they communicate through this thing called the intercore message bridge. And what happens is a high-level core sends a message via the intercore message bridge to the real-time application. Now, in the real-time application, it's running, as I said, Azure RTOS ThreadX, and there is a thread that is listening out for incoming messages. So what will happen then is that that thread will send a message to another thread, and that other thread's responsibility is to go and measure the environment. So go and measure the temperature, humidity, and air pressure. So when that thread has completed that, what it will do is it then will send a message back to the high-level application via the intercore message bridge. And then what the high-level application will do is that will then proxy or basically forward that message onto IOT Central. So that's what's going on. So that's the flow. So we've got the high-level application sending a message to the real-time application. It's processing that and sending a message outbound to the high-level application. Now, keep in mind, I'm showing a flow, one-way flow. You can have bidirectional flow, but for simplicity and the way that this application works, it's the high-level application sending a message to the low level. But there's nothing to stop the real-time application also initiating the communication with the high-level application. Okay, so what we're going to do now is a quick demo and just kind of show you how this works. So what I've got here is I've got Visual Studio. So I've got Visual Studio Code. In fact, if I just jump back to that slide again, sorry, you'll notice that what I've got here is that the real-time application is color-coded red and the high-level application is color-coded blue, just so you can help keep an eye on what's going on. So I've got two instances of Visual Studio Code loaded up here. So the one that's highlighted in red maps to the RTOS, Azure RTOS real-time application. Keep in mind, this application is going to be running on the Cortex M4 core on the Azure Sphere. And I'm not going to go into this a lot of detail. Azure RTOS is a whole session in its own right. But as I mentioned before, has a threading, it's a preemptive threading service. And the idea behind this is you go and create threads. And as I mentioned before, there are two threads. There's one thread which is listening for messages, and there's another thread that is responsible for actually measuring the environment. And I'm just going to scroll down here down to the read sensor thread, and I'm going to put a breakpoint just there because I know what's going to happen. The application, the high-level application, ultimately will call onto this. Now, what I'm going to do now is press F5 to deploy the application to the Azure Sphere. So that'll take a moment to compile that code, and you'll see down the bottom right-hand corner, you'll see there's a note there saying deploying the application, and now it's starting the application, And then what's happening is that the debugger is being attached to that instance that's running on the Cortex M4. So I'm just going to leave that service running there for a moment. And what we're going to do now is we're going to bring up the other instance of Visual Studio Code. And in this window here, this is blue. So remember, color-coded blue from that slide, this is the high-level application. So this is the Azure Sphere high-level application. Now, inside this application, one of the first things I want to talk about, in fact, this is true of the real-time application too as well, so I missed this, is something called the app manifest. Now, as I mentioned before in this talk, every resource that you want to access from an Azure Sphere needs to be defined in this template. If it's not defined in this template, then your application will not be able to access that resource, be it hardware or be it communications, network endpoints, and things like that. So everything has to be defined. Otherwise, the application will not be able to access. Essentially, what we call is secure by default or locked down by default. And it means if by chance there was either an application bug or a device got hacked, and an unlikely event the device got hacked, then there are multiple layers of security. And this is one of those multiple layers of security. And just to kind of give you a bit of a sense, we're defining GPIO. So this is the peripherals, GPI peripherals that we want to be able to access. So we want to access the relay, and we want to access another LED called the network connected LED. This application is going to be talking to that real-time core component. You need to specify the GUID for that real-time application. And these are network endpoints that have been enabled. And these are all the network endpoints for the IoT Central application. Now, there is a tool that you run to generate this information for the ITC endpoints. So don't look at this and say, my God, where he's got that from. This is all documented in the learning module. Okay, so the next thing I'm going to do is go across to main.c. Now, this application here is, again, part of the learning module. Now, it's also comprised of a set of helper libraries. And you'll see that called the Learning Path Library. Now, I just want to emphasize that that Learning Path Library was built using the Azure Sphere SDK samples. So if you go and look at the helper libraries and look at these samples, you'll see there's a lot of crossover. I've written the helper libraries really to help facilitate your learning experience. You'll find that it's all C, and there can be a lot of duplication of code. And effectively, the learning libraries help kind of simplify that process. These are the boards that are supported. So all the 3 boards from Avnet and Seed Studio. And as you'd expect for all C applications, there are a set of include files for the application. There also include files for the system. And we've also got the shape of the JSON packet that's going to be sent from the IoT, from the Azure Sphere application to IOT Central. So that's just what the JSON is going to be looking like. So the first thing I'm going to do, and the model is very declarative, and you'll see this as I go through in a moment. The first thing I'm going to do is I'm going to add in a timer. So what you'll notice that with this module, it's very declarative based. The idea behind this is it reduces the amount of code you need to go and write. So what I'm declaring here is that this is a timer that's going to read the sensor, and the period it's going to read this is every 5 seconds and 0 nanoseconds. And it's going to call a handler or a C function called read sensor handler. And the next thing we need to do is we need to initialize that. So I'm just going to add this to what I call sets. So we'll add that to a GPIO, to a timer set, sorry. And what happens further down the code, there is a function that gets called. This set gets passed to that, and then it will automatically be started up for you. And we need to implement this handler called read sensor handler. So I've got some code over here, and we're going to copy that into the demo section, and I'm going to put a breakpoint here. Now, as you remember in that slide, remember this high-level application is going to send a message to the real-time application, which is currently running with the debugger attached to it. And it's going to send a message, and it's going to say to that core, I want information about the environment sensor. It's just basically a format for defining communications. And then what's going to happen is that when that real-time application has measured the environment, it is going to send a message back to the high-level application with that data. And I'm just going to put a breakpoint just over here. So when the real-time application responds, it'll hit that breakpoint there. So what I'm going to do now is press F5 to deploy this application. So it goes and compiles it. It would deploy that application to the Azure sphere. And then the next thing it will do is it will start up the debugger. So that's the general process, and that's the way that things happen. If I now go and click on the Output tab, what you'll see is that there is some work goes on to authenticate the device to IOT Central. It's actually via the device provisioning service. So you see there that the hardware security module is clicked in. And what we're going to see now is that this application here, so this is in the C function called read sensor handler. This is now, when I step over this code, it's going to formulate the command or the request to the real-time application. Now I'm going to send that message to the real-time application. Ship that through. Now, what happened there is if I pop across to the real-time application, you'll see that this real-time or the Azure RTOS application stopped at this breakpoint. So it received the message from the high-level application, and it's now stopped at the breakpoint in this Azure RTOS application. And we'll just step through this. So the first thing it's going to do is going to get the temperature. Next, it's going to get the pressure. I generate a random humidity because there isn't a humidity sensor on the device. And then the next thing it's going to do is send a message back to the high-level application with the, I'll just take those breakpoints off, with the information in it. So what I'm going to do now is pop back to the high-level application and just let these queue up. Okay, so now the high-level application has received the message from the real-time application. It's a C function called intercore handler, and you'll see further down the code that I basically map this C function to when I receive messages that come through from the real-time application. And I just step through this code here. So I get hold of the humidity, 51, and the pressure is 1012, and the temperature is currently 31. And I can promise you it's not 31 degrees here in Sydney, Australia, that just the sensor hasn't been calibrated. And we'll just step through that. And the next thing I'm going to do is log that information into the output screen. So if you look down at the bottom of the screen here, you'll see that that information there has been serialized into a JSON format packet. And I'm now going to send this message to IOT Central. And what I'm going to do is just take that breakpoint off. And we should now have this application sending a continuous stream of data up to IOT Central. So hopefully that's reasonably clear what's going on. So we've got these two cores that are running a high-level core application and the Azure RTOS running on the real-time core. And you can see how the activities get coordinated between both those cores. Now, if we switch across to Mustafa, your machine, and go to IOT Central, and we're going to look in the telemetry, and hopefully the data would start to appear on the dashboard. So you'd like to share your screen?
Yes.
Great.
So
okay, cool. Go for it.
So this is the telemetry data that we are viewing, and yeah, you can continue with you.
Yeah, great. Now, when you're building these applications yourself, keep in mind that it will take a moment for the data to show up in the dashboard. It's not because the data is taking a long time to get up into IoT Hub and IoT Central. It's just IoT Central has a refresh cadence of every, typically about a minute to 2 minutes. So keep in mind that you need to look at that. Now, Mustafa's just popped across to the raw data field. In fact, if you just go across to raw data and just going to expand one of those data elements, so click on the, yep, perfect. Click on that, and you can see the raw data coming through as well. So it kind of gives you another view on the data. Great, thanks very much. I'll just switch back to my screen. Okay. So back on the slide. So hopefully that was clear as mud. Remember, we had the high-level application sending a message to the real-time application, the Azure RTOS ThreadX application. It would receive that message, sent a message to the sensor thread, it did the measurement, sent it back to the high-level application, and then forward that message onto IoT Central. Okay, so the next thing we're going to do is show you how you can control a lab light. So you can imagine, in this case here, you want to be able to remotely control the lab lights. Now, this is obviously super applicable to a whole range of scenarios. Look, it could be controlling lights in a factory, in a smart city. You could be turning fans on and off. You could be turning machinery on and off. Super applicable, but a light is easy because I can show you kind of an action. And I'm going to show you how this works. So as I mentioned before, IoT Central is an application in its own right, which builds on top of IoT Hub. And the way it works is that IoT Central has this idea of what we call commands. And I've defined a command, and you'll see it inside the JSON document that Mustafa imported when he set up the IoT Central template. And we're going to invoke a command called light control. Surprise, surprise, because we're going to turn on a light on and off. Now, what's going to happen is IoT Central will make a request to IoT Hub, and it will ask IoT Hub to forward on a message to the device to invoke the light control direct method. IoT Hub will then bundle up that message and send that message to Azure Sphere. Azure Sphere, you define it to say, looking out for these messages. So Azure Sphere will say, with the appropriate code, saying, I understand that request. I'm expecting a request called light control, and I have a handler that I'm going to call, a C function that I'm going to call. I'm going to apply that action, and then I'm going to report back to IoT Hub, and then as part of that request, the original request, back to IoT Central. IoT Central will say, okay, that request either succeeded or it failed. There's a status code. So that's what's going on. How this interaction is going on. Of course, you could go and build your own IoT Central, your own application. This is fundamentally how these style of applications work, and that's how IoT Central works on top of IoT Hub. So what we're going to do now is a demonstration about how this interaction works. So we're just going to stop this application. So remember, blue is for high-level applications. It's for the high-level application, the application that's running on the Cortex A7. So the first thing I'm going to do is I'm going to declare the GPIO pins required, the services required to turn on the light. So in this case here, I've just called the declaration here called relay, and it maps to a pin called relay. And further down in the infrastructure, it maps obviously to a physical pin number. And what it's going to do is, we're going to set that up. And I'm going to initialize that. So down here in what we call these sets, I'm just going to add that to that set. And as I said before, further down in the code, there is a call that will look for all the relays, also all the GPIO pins defined in this thing called a GPIO set, and it will go and initialize all the GPIO that are found in this array. And then the next thing I need to go and define is what we call a direct method binding. And this will tell, this basically sets up the device to say, okay, if I receive a direct method called light control, I'm going to call a C function called light control direct method. And I need to initialize that as well. So down here, we've got what we call direct method bindings. And I'm going to add a reference to this. And as I mentioned before, same deal, further down in the code, there is a function that gets called, which will initialize all direct methods that are found in this array. And then, of course, I need to go and implement the handler for this. So remember up here, the handler is called light control direct method handler. And I'm coming down here and add in the code for this. So this is the code for implementing the handler. I'm going to set a breakpoint. In fact, what I'm going to do is to remove all the other breakpoints that might still be there, and we'll set a new breakpoint. Excuse me. Okay, so I've just pressed F5 to compile this code. The code is now going to be deployed onto the sphere, and the debugger will be attached. Now, while that's happening, I'm just going to check if there are any questions. There aren't any questions at the moment. So if you have any questions, then please feel free to ask them on Twitter on that hashtag LearnTV. So what we've got now is that the device is starting up and it's setting up the security to IOT Central. And it's now going to start sending messages up to IOT Central. So what we're going to do now is we're going to switch back to Mustafa's machine, and Mustafa's going to show you how you can control the light and turn the light on and off.
Yes, thank you, Dev. So you can see my screen, right?
Not yet.
Now?
Now we can. Perfect.
Okay. So as we can see, we can head over to command, and because of that JSON file that we uploaded in the starting in the device templates, so this light control is created over here. All I have to do is click on light control and then run it.
Okay, great. So I'm going to switch back to my screen. So thanks for Mustafa. So we're controlling this device from India, and I'm going to go back to my machine, and you'll see in my code, you'll see that the that action has resulted in the C function being called. Remember, it's called light control direct method, and it's hit that breakpoint. And now as I step through the code, step through this, and if I hover over state, you'll see that the state is now true, and that's going to turn on the relay. And if I hold the relay up high enough, hopefully that will turn the light on. Perfect. Now, Mustafa, can I go and get you to turn the relay off? So just go and run that command again without being ticked. Okay, so that's now hit the breakpoint again, and we will step through that. And if I hover over state, you'll now see that's false. And surprise, surprise, this is going to turn the light off. So you can see how the direct methods are being used and how IoT Central is using those commands, which map down to direct methods in IoT Hub and how those work. So thanks so much for that, Mustafa. So we're going to switch back. In fact, just before I do that, I'm just going to remove the breakpoints. I'll just double check any questions. No questions yet, but do feel free to ask any questions as we kind of go along. Okay. Alrighty, so the next part we're going to talk about is how we can change the rate in which we go and measure the lab environment. So you can imagine that, hey, when you first set up this lab environment, or you're monitoring the lab or a smart city or a smart home or whatever it might be, you might have decided, hey, look, measuring the lab environment once a minute was just fine for our purposes. But then someone came along and said, well, actually, we've got an experiment here which requires more kind of proactive, more regular monitoring of the environment. And so in this case here, you want to be able to change the rate in which the sensors are measuring the environment. And this is kind of what this is about. So now in IoT Central, it has a notion of properties. And you'll see that in the user interface. In fact, when Mustafa created that template, he went and named one of the tabs properties. Now, the way that properties work in IoT Central is IoT Central, in this case here, we've got a property called sensor measure rate. And what that will do is that will make a request to IoT Hub. So there's an API. As I mentioned before, IoT Central is an application that Microsoft's written, but if you're writing your own application, this is how you would go and write your own application as well, your own kind of cloud application or mobile application. You would send a message to IoT Hub. IoT Hub will then bundle that message up and then store that message into what's called a device twin. Now, every device that is created in the IoT Hub has what's called a device twin. Now, a device twin is a JSON document which has a representation of the state of the device. And you can basically, there are effectively three areas. You can go and do what are called tags, which are more cloud-centric state, but you can also have what are called desired properties. So you can see what we're going to do here is we're going to set what's called a desired property. When we set the desired property, a message will also be sent to the device. And the device will say, okay, with the appropriate code on that device, say, okay, I understand a device twin. In this case, a device twin is called sensor measure rate. And I have a handler for that. I have a C function that I'm going to call when I receive a message from IoT Hub, which is a device twin. The next thing I'm going to do is I'm going to call the function which implements that. And then I'm going to respond back by updating the device twin reported properties. So now we have a cloud view of the device state. And that means that IoT Central can then go and query that device twin to understand what the state of the device is. Now, of course, the beauty of having this device state in a JSON document and a device twin and the cloud, it then means that you can go and query all the devices that you have deployed and find out what their current state is. Of course, the other way of doing that is, of course, you could go and ask every device, hey, what's your current state? What's your current state? What's your state? And if you had thousands of devices, clearly that would not scale very well. So the whole idea behind these device twins is you have a cloud view of the device state that you can control from your application, and then you can query that cloud state from your application. In this case, the application we're going to query using is IoT Central. Okay, so what we're going to do now is demonstrate how this works. So I've got a bit more code that I'm just going to add in. So I'm going to declare what we call a device twin binding. And as I said before, these structures are defined as part of the helper libraries that I've written just to facilitate the overall process. And the idea behind it is very declarative, as you would have spotted already. It just makes coding for these kind of scenarios less error prone. So further down here, what I'm going to do is I'm going to add it to the device twin binding set. So we'll add a reference to that. And further down the code, there is a function that gets called, which this device twin binding set gets passed in, and all the device twins that are referenced in this set will be initialized. And then I need to go and put in a handler. So this device twin binding here, the twin property name is called sample rate seconds. And when the device receives a device twin request, it will call the C function handler called sample rate device twin handler. And we're going to implement that into the code. What I'm going to do is I'm going to set a breakpoint in here, and I'll step through the code. So we'll just stop the existing code that's running on the device. I'll press F5 to compile that code, to deploy that code onto the device, and again, attach the debugger, and then the device will start up and set up the secure connection to IoT Central. So what we're going to do now is we're going to switch across to Mustafa's machine, and he's going to show you how you can go and set the sensor sample rate.
Yes. So you can see my screen now?
We can indeed.
Yes. So you can head over to properties, and then you can see sample rate over here. Let's set the sample rate to 8 seconds.
Perhaps set it down to 2. Mustafa, set it to 2.
I'll make it 2. And then so you can see something over here as accepted 4 hours ago. What it does is it shows your desired state and your reported state, last reported state. So now as I put the desired state as 2 and the last reported was 6, all I have to do is click on save.
Okay, cool. So I'm going to hop back to my screen. And you'll see what happened when Mustafa set that sample rate. You'll see that the code on the Azure sphere stopped at that breakpoint that I set in the code. And if I hover over sample rate, you'll see that, surprise, surprise, we've now got the sample rate which corresponds to the value that Mustafa set in IoT Central. So the first thing I do, and what all good applications, all good IoT applications in general should do, is you should go and validate that samples is sensible. In this case, what I'm just doing is greater than 0 and less than 5 times 60 seconds, so less than 5 minutes. And what I'm going to do now is step through this code, and I'm going to change the timer that is responsible for reading the sensor. Excuse me. So I'm going to change the timer now to the sample rate over here, which is 2 seconds. And so I'm going to change the timer, And then the next thing I'm going to do is I'm going to send a message, a special message back to IoT Hub, which will ultimately find its way back to IoT Central. And I'm going to acknowledge that desired state. So what I'm going to do is I'm going to set the reported value in the JSON document, which is a device twin for this device. So I'm going to do what's called an acknowledgement. And I'm just going to acknowledge that, yep, I've set that state on the device and you've now got a copy in the cloud. Okay, and in fact, Mustafa, not that we actually practice this, but if you want to hop back to, you share out your screen again.
Yes.
And if you now go and look at the just toggle away from the, yep, and then go back to properties. And you'll see it's now been accepted. And you'll see that go back and click on that again. And what you'll see in there is that the desired state and the reporting state, the version, are the same. So they're both now version 7 of both the desired state and the reported state. So that's how you can tell. That's how IoT Centrals can tell that the reported state has been updated on the device. Okay, thanks for that. Sorry about that, Mustafa. I know we didn't go through that beforehand. So hopefully it kind of gives you a sense here of what's going on between the device. You can go and set that sample rate, and you can go and set the device twin and via the property fields in IoT Central, and you can control that device. So that's pretty neat. Okay, so those are the demos. So just to kind of wrap this session up, we're just going to do a quick knowledge check. So out of what we covered before, so in the Azure Sphere ecosystem, which component is missing from the following list? So remember I mentioned the Azure Sphere SDK you need to install. You can develop applications on Windows and Linux, and it's very much a C development environment. This is a microcontroller, very constrained environment. So it's C, and you need to have the SDK installed. You remember I mentioned before that you need to have the Azure Sphere tenant. You create one of those, and you need to claim your device, and you need to be authenticated in that tenant, and you can only build applications for your Azure Sphere from a tenant that you own and that you have authenticated against. And you remember that we have the Azure Sphere OS that you need to update. So which component is missing from this list? So we've got the Azure Sphere SDK, we've got the tenant, the OS, and which one is missing? So I'll give you a moment to think about that. Just check for questions. Okay, and the answer is you should have an Azure Sphere security service, which is kind of a fundamental part of an Azure Sphere device. Now, Mustafa, can you talk about this question, please?
Yes, sure. Thank you, Dave. So let's suppose your organization created an Azure Sphere tenant and then claims each of its devices into that tenant. What function does this accomplish? So we have the options over here. I'll give you a moment to think about it. And yes. So, and the answer is so that you can manage those devices remotely and securely.
Okay, that's great. Thank you very much. Now, I did just spot a question. Do we have to use the HSM for security with the Azure Sphere? So the HSM, so it stands for Hardware Security Module, is required to authenticate that device against the Azure Sphere security service. But you can use other security mechanisms. So for example, you might want to talk to your own backend service. Maybe you've deployed some device which is running let's say it's running a machine learning service on a larger device sitting inside a factory or on your home or in a smart building. Then yes, of course, you could use your own security mechanisms to authenticate that device. So the Azure Sphere is by no means limited to only connecting to IoT Hub and IoT Central. You can connect to a whole range of services. The most important thing about this is you need to have defined the network endpoint in the app manifest that you want to communicate with. And then you can have like an X509, for example, authentication with that backend service or password and username, if you really must, to backend services. So yes, you can absolutely authenticate those devices with different mechanisms. Thanks for that question. Okay, and so really in summary, so IoT Central, the beauty of IoT Central, as you saw before, it doesn't require development skills. It's very much the idea behind this is that you can either define your own template, you can use a template that I've defined as part of the learning module, or you'll find there are a lot of devices out there in the marketplace which already have a capabilities model that has been defined for that device. Then you go to the manufacturer and say, hey, look, do you have the JSON file for this? They say, yep, here's a JSON file for IoT Central for what's called IoT plug and play. You would import that into IoT Central, then go and define the user interface of your dreams, charts, kind of things that you're interested about, and then you're going to build your application behind that. So IoT Central, very much no developer skills required, very much drag and drop, but you also have the ability to extend it. So you can extend, for example, with rules. So for example, you might want to send an email. So, hey, look, the lab temperature has gone above 30 degrees, for example. Send an email to the administrator saying, hey, look, we think there might be a problem in this lab or this smart building, this factory, whatever it might be. And you can also take the data that's gone into IoT Central and you can feed that flow into things like Azure Event Hubs and store into storage and things like that. So you can do lots of things with IoT Central over and above what you can do kind of with the initial user interface. Can't help overemphasize that security needs to be part of your IoT story. Now, the demonstration I've shown you today is with Azure Sphere. And as I said, the main business value or the main technology value behind Azure Sphere is that it's a highly secure device, secure by default. Of course, everything I've shown you today, you could go and do with a Raspberry Pi or an ESP32, 8266 or an ESP32 or an Arduino. But what I want to get across to you is Azure Sphere is a highly secure device. And if you're building projects, then you should absolutely be considering it because it is secured by device. And none of us want to be in a situation where we can't update our device because we've got a security issue. So Azure Sphere is really around delivering highly secure IoT devices for a platform. And you also keep in mind that so Azure Sphere is secure by default with ongoing updates. Now, as I mentioned at the beginning of this talk, you will find all the learning notes inside the IoT Central module. You'll find all the documentation there, as well as all the source code. In fact, the sample that I showed you today, if you delve and have a look in the samples directory, you'll find actually the kind of the run through that I went through today with all the code in that as well, just to break it down for this talk. Now, in terms of other events that have happened, these have actually all happened in the last week or so. These are all available online now. So you'll find talks there for creating IoT Edge, so using DevOps for building IoT Edge solutions. Last week, Mustafa and I talked about creating IoT solutions with Azure Sphere and IoT Hub. There was a talk earlier this week, which was about building cognitive services with IoT Edge. So that's a super interesting talk. And today's talk as well, which is around using IoT Central and Azure Sphere. And we extended that to using Azure RTOS as well. So we will keep an eye on Twitter. So please feel free to ask questions on #LearnTV. And really, if you also feel free to connect to myself on Twitter, on D Glover, and there goes my LinkedIn. And I'd also like to thank Mustafa for taking time out. In India at the moment, I think it's probably coming up to 2:30 a.m. in the morning.
Yes.
So I'd like to thank you very much, Mustafa, for taking the time out for this as well. So.
Yeah, thank you, Dave, for you as well. You taught me so much during these sessions. It was literally a lot of things. You can read on the internet and then you can learn from I learned from you as well. Thank you for giving me the time, like in the morning, in the afternoon, all those time. I know you are like more busy than me. I'm just a student right now. So thank you for that
No,
as
that's cool. That's part of the day job. So that's great. And feel free also to follow Mustafa on Twitter. So it's I am missed you.
Yes.
And also feel free to add him on LinkedIn. I'm sure he'd be very happy to hear from you as well. And thank you very much for linking up today on this session. As always, stay safe and have fun building highly secure IoT solutions. Get hold of one of those Azure spheres, play around with IoT Central, and have a lot of fun. Thank you very much.